So look at this situation. So it is integration of the form. So what will happen? In the numerator you will be having sin x plus cos x or sin x minus cos x. If it is not available, then create it. You have to create sin x plus cos x or sin x minus cos x. And in the denominator you should have sin x and cos x together. Okay, so the idea is you will have sense of sine and cos together. In those cases you have to create sin x plus cos x or sin x minus cos x accordingly. Okay, now just listen these words, it will help you guys a lot. What you have to do, you have to take z as something. So what is that something? So you will be taking sin x plus or minus cos x. Okay, so when you will consider plus x, when you will consider minus x, I will tell you. But at the end you have to consider sine of x plus or minus cos x. Now suppose that you have taken z as sin x plus cos x. So what will be the differentiation? So dz by dx will become cos x minus sin x. So if there is a chance that you can create cos x minus sin x, then you will be taking z as sin x plus cos x. Okay, now suppose that you have differentiated this one dz by dx, so it will become what? Cos x plus sin x. Now look at this, after differentiation you can create this. So if you can create sin x plus cos x, you should take z as sin x minus cos x. And if you can create, if you have to create cos x minus sin x, you have to take z as sin x plus cos x. Now what we will do with this replacement, how we will replace sin and cos x? So suppose that in both the cases it is applicable. Suppose that you have taken this thing as z. Okay, so you have to make sine and cos together. So what we will do? We will do squaring both sides. So it is sine square x plus cos square x plus 2 sin x cos x. Correct? So don't you think it will become z square minus 1 by 2 sin x and cos x together? So you will be replacing sin x and cos x by using z square minus 1 by 2. Same way you will do it here, squaring both sides. You will be having sin square x plus cos square x minus 2 sin x cos x. You have to create 2 sin x cos x, so you will send this thing that side. So it is 1 minus z square by 2, which is sin x cos x. Okay, so you have to think a lot while solving these kind of questions. Okay, now let's crack this question. So look at the denominator. In denominator, sin and cos are together, correct? So we can think about the current form. Okay, and the numerator is having sin x plus cos x. So by hit and try, let's assume, let's pretend, you know that we have to take z as sin x plus or minus cos x. So for time being I am taking sin x plus cos x. Okay, so if we will do differentiation, dz by dx, we will be having what? Cos x minus sin x. It is not helping you, na? Means you should create the differentiation. So what we will do? We will take z as sin x minus cos x. So it is dz by dx will become what? Cos x plus sin x. Yes. things are going in correct direction. Now you have to later replace sine and cos. So what we will do, we will be squaring both sides to this equation. So z square equals sine square x plus cos square x minus 2 sin x cos x. Correct? Now, so we will have sin x cos x as 1 minus z square by 2. Correct? Now do the replacements. So look at this. So numerator directly will be replaced by dz, and the denominator will be like 2 plus 1 minus z square by 2. So we will have 4 plus 1 5 minus z square. So 2 times integration of dz by root 5 square minus z square. Okay, so we have to apply the formula. You know that if it is without root, you will be having 1 by a or 1 by 2a. It will be 1 by a if you are comfortable. If you are not comfortable, you will be using 1 by 2a. So do you think you are comfortable in this case? No, we are comfortable with a square plus x square, but this is a square minus x square, so we are not comfortable. So if we are not comfortable, then we will be using 1 by 2a. A is root 5. And if we are comfortable, we will be using tan. If we are not comfortable, we will be using log. And if x is bigger, we should write x minus a in the numerator, but if a is bigger, we will write it in the denominator. So root 5 minus z, and then root 5 plus z. Okay, and plus integration constant c. You know that you have to answer in x, so again do the manipulation. So it is log root 5, who is z? Sin x minus cos x. So plus sin x minus cos x, and then root 5 minus sin x plus cos x, and then we have integration constant c. I hope the idea is clear and you guys can connect with these kind of situations. Now I'll give you the brief idea about this question. You know that here we have a tan and cot inside root, and we don't know how to integrate. So let's do it. So we will break down this into sin and cos. So it is root sin x by cos x, and then plus root cos x by sin x. Correct? Now take the LCM. If you will take the LCM, you will be having sin square x, means you will be having sin x plus cos x, and then denominator will be sin x and cos x. So after simplifying, you guys can observe that you have sin and cos together, and you have sin x plus cos x in the numerator. Correct na? So what we should take? We should take z as sin x minus cos x. And I hope after this you can manipulate this question. If you are not able to do it, please comment in the chat box so that we can respond accordingly. Okay, now let's move on to this part. So look at this situation. So the numerator is totally fine, but the denominator, look at the denominator. So we will simplify the denominator first because we want a single angle. So cos x minus sin x upon root over 8 minus, I'll be applying sin 2x formula, 2 sin x cos x. Now be super slow. If you will observe the denominator, sine and cos are together, and on the numerator you have created sine and cos as well. Okay. So what we should do, you know that I will be taking z as sin x minus, no, sin x plus cos x. So dz by dx will become what? Dz by dx will become cos x minus sin x. Look at this. This is clear, no? Okay. And you can replace this by using squaring both side to this part. I hope now you can connect with this one. Also, you have to apply the formula. In the denominator, you will be having a square minus x square or a similar situation. Okay, let's move on to the next part. Now, look at the beauty of this question. Here, they have given you only sin x. They haven't provided you sin x plus cos x or sin x minus cos x. So, it is your responsibility to create one. So you know that if we will have, sir, if we will have cos x with this question, no. So 100% I can solve this question, or minus cos x also. But suppose that if you have added cos x, so don't you think that you have to subtract cos x as well? And you will be solving one question, but you will feel trapped in other question, no? Earlier you are having one sine, this time you will be having one cos. Okay, so how we will get rid of this situation? Just look at here. What I will do, I will multiply and divide by 2, and look at how I will this distribute this 2. So it is sin x cos x. I'll be giving you hint only. Okay, so 1 by 2 integration of, now look at this, can I write sin x plus cos x plus sin x minus cos x? Look at this, we have created two pairs and things are resolved, correct? So you should have command over these kind of manipulations. Okay, now look at this. Now you can convert your one question into two questions and you can solve accordingly. Sin x plus cos x upon root over 1 plus sin x cos x plus 1 by 2 integration sin x minus cos x, and then denominator will be 1 plus sin x cos x dx. I hope from here you can proceed. You know that in this case you will be taking sin x minus cos x as z, and in that case, means in the next case, you will be taking z as sin x, not z, but you have to take different variable. Suppose it is y. So sin x plus cos x, and you can respond accordingly. Okay, I hope you guys are getting the ideas how to crack, and you guys are like getting comfortable with the manipulations that we are using in this chapter. Okay, now the point is you have to revise a lot. This thing will help you guys, otherwise it is tough to solve integration problem. Okay, so just have great command over the manipulations and try to revise a lot. Try to revise the formulas, try to revise the types. Don't try to memorize, but revise a lot. If you will revise a lot, it will stick in your mind. Okay,